had a student ask a question about how to do an analysis of variance or ANOVA when you had 4 data values in each group or 4 groups. And so I'm going to create a quick little video. This is actually one of the problems in the practice problem set for ANOVA. And I'm going to walk you through the questions that you might see on the practice problems as well as the homework problems and final exam. So the question reads, initially, 4 different traffic routes are tested for mean driving time. The entries in the table or the list that you see there are the driving times in minutes on the 4 different routes. At the 0.05 level of significance, are the mean driving times similar regardless of the routes? And then it gives you the data information. Okay, so one of the first questions that they ask you in the homework or the practice problems is, how many groups are you dealing with? And so that's a relatively easy question if you look at the problem here, because it tells you that in several different ways. One is in the first sentence, it says 4 different traffic routes are tested. And you can also see here in this list 1, 2, 3, 4. So we have 4 groups that are being tested. It also asks you if you have qualitative or quantitative data. Here again, if you'll kind of look, it's there in several different places because it tells you that the values represent mean driving time. So it represents time. Later it tells you that it's in minutes. Also notice that you're given numbers. And while in most cases, qualitative data does not include numbers, okay, so that's kind of a safe bet. We're measuring the mean driving time because we have quantitative data. Actually, what you have here that helps you to recognize that it is an ANOVA, or that you should conduct the analysis of variance test, is you have quantitative data. You have those numbers that are sorted into groups by a qualitative variable. My qualitative variable, or what I used to sort into groups, were the different routes, and I had 4 different routes or routes for the traffic. Okay, then we kind of begin the hypothesis test, and the first step in any hypothesis test is to state the hypotheses. Okay, so we need to initially state the null hypothesis and the alternative hypothesis. Now, in the practice problems, in the homework problems, and on the final exam, that's asked as 2 separate questions. One of the key things here that I would remind you about is that, remember that the null hypothesis in some form must contain equal, and then the alternative is the opposite, which is not equal. And typically the relationship you're looking for with ANOVA is equal or not equal. They're either the same or they're not the same. We usually write the hypothesis out in words, and the way we would write it here, we would say all the mean driving times are the same. You can use that phrase. You could say all mean driving times are equal. There's various ways to say it, but that's the easiest way because the idea of being the same implies equal. The alternative is at least one of the mean driving times is different. Or you could say is not the same. And it only takes one being different for them not to all be the same. And guys, pretty much across the board for ANOVA, that's how you're going to state the null hypothesis and the alternative hypothesis. All of the mean, whatever the variable is, are the same. And then the alternative will be at least one of the mean whatevers is different. Then we really don't have a lot to identify here in terms of identifying the players, because all of the information that we need in terms of identifying the players are given here on our in the table in the problem. And I'm going to scratch these down for just a minute so we can transfer them into the website. Okay, so let me get them written down. Give me just a minute. Okay, then we're going to go out to the free website, and I'm going to do that in just a minute. Okay, so we go out to the free website. Now, one of the things that may challenge you here is that you only have blanks for 3 groups, but it's okay. Okay, so we click in the first box, it turns blue, and I'm going to start entering the data, and we separate the data values by commas with no spaces. So we do 30, comma, 32, comma, 27, comma, 35. That's the first group. Then I move to group 2. I click in the box, it turns blue. Okay, and I type 28, comma, 36, comma, 35, comma, 71. I click in the third box. Okay, again, it turns blue. Okay, I have 22, comma, 21, comma, 19, comma, 23. Now, I don't have a fourth box, but notice these buttons here at the bottom. Underneath the last box or right above the calculate, you can add a group or you can delete a group. So I need to add a group. So I'm going to click on add group, and it inserts a fourth box for me. I click in the box, it turns blue, and I enter 25, comma, 29, comma, 28, comma, 35. So I have all 4 groups entered. Each group had 4 data values. I have them all entered, and I'm going to click on calculate. And the information that you need as far as the results, if you'll look here near the bottom, analysis of variance results, and right here you have F statistic value and the corresponding p-value. Okay, so F in this particular problem is 3.03. The p-value is 0.07107. Okay, so I'm going back to my piece of paper, because typically the next question that's asked is what is your F test statistic and what is the corresponding p-value. Okay, so I'm going to write those things down from the website. So F was calculated to be 3.03, and its corresponding p-value is 0.07107. Then I need to make my decision about whether to reject or fail to reject the null hypothesis. To do that, we compare the p-value, which we just got from the calculator, to the level of significance that was given in the problem. So we have 0.07107 compared to 0.05. Again, the easiest way to do that is to compare it digit for digit. So if I compare the first digit after the decimal to the first digit after the decimal, there appears to be no difference. If I look at the second digit after the decimal, I have 7 compared to 5. 7 is greater than 5, so the p-value is greater than alpha. When p is greater than alpha, the guideline says we fail to reject the null hypothesis. Now, again, thinking about what that means so that you can ultimately write your conclusion. If we fail to reject the null hypothesis, that means that our null hypothesis is true based on the evidence that we have, okay? And so when we write our conclusion in terms of the null hypothesis. Now, I've run out of space at the bottom of my paper, so I'm going to write my conclusion up here at the top, and so it would read I don't know why it's highlighting. Okay, at the 0.05 level of significance, the mean driving times are the same or similar regardless of the route or route. Okay, because that's what, if you go back and look, that was the statement in the null hypothesis. We confirmed that the null hypothesis based on our evidence was true, and that means the alternative would have been false.